Here's a resistivity question that wants to know how long a cable is. Once again, we use our same formula. R equals rho L divided by the area. Okay, so resistivity equals rho times the length divided by the area. So we know our resistivity because it's copper, so it's going to be 1.72 by 10 to the negative 8, and we know its area 2.5 millimeters squared. There's our area, there's rho, and what we know our resistance is 6.5 ohms. So what we're after in this case is the length. So we can rearrange that formula to get rho L equals R times A, and if we know that rho L equals R times A, we can divide both sides by rho. Divide this side by rho will give us length, and then divide this side by rho. So that one there disappears, and we wind up with L equals R times A divided by rho. Once we've got that, we can just put our numbers straight into that rearranged formula that we've got. So our length will equal R 6.5 times area 2.5 by 10 to the negative 6 meters squared, all divided by rho, and rho for copper is 1.72 by 10 to the negative 8 ohm meters. Put that in our calculator, and that equals 944 meters, close to a kilometer long. Let's look at this question here. If an aluminium cable is 2 kilometers long and has a resistance of 9.33333 ohms, what is its cross-sectional area? Right, let's put down our formula that we use. Resistance equals rho times the length divided by the area. Right, so we've got our length there, 2 kilometers. Rho, aluminium, we know that rho for aluminium is 2.83 by, whoops, let's go there. Okay, we know that rho for aluminium equals 2.83 by 10 to the negative 8 ohm meters. So we've got our rho, we've got our length, and we've got our resistance, and we just need to know the area. So we've got to rearrange this formula. If resistance equals rho L over A will equal rho L over R. There's our new formula. The area of the cross-sectional area of the cable equals rho L divided by its resistance. Then we put our numbers in. Rho is 2.83 by 10 to the negative 8 ohm meters times its length, which is 2,000 meters. 2 kilometers is 2,000 meters, and we divide that whole thing by its resistance, 9.3333 ohms. Put all that in our calculator. We can do a bit of cancelling if you want. You got 2,000 there. You can knock that off there. You can change it to 2, so that would be negative 5. But anyway, put it all in your calculator, and we'll see what answer we get. You get an answer around 6 by 10 to the negative 6 meters squared. 6 by 10 to the negative 6 meters squared, which is the same as saying 6 millimeters squared. So that's the cross-sectional area of our cable.